Every day, we walk on roads, cross bridges, live inside buildings, and admire tall skyscrapers. But have you ever wondered, what keeps them standing strong against gravity, wind, and earthquakes? Is it just bricks, steel, and cement? Or is there something deeper? The answer is physics. Physics is the invisible engineer that ensures every structure we build is safe, stable, and reliable. Physics is the foundation of all engineering. It is not about solving abstract problems alone. It is about applying the laws of nature to real-world challenges. Civil engineers must constantly deal with forces, motion, and energy. Without physics, designing a dam or a bridge would be nothing more than guesswork. With physics, we can calculate, predict, and ensure that every structure stands firm for decades. Think about this. A bridge must carry the weight of cars, trucks, and people. A building must stand tall even when strong winds blow. A dam must hold back millions of liters of water without cracking. All of this is possible only because civil engineers apply physics. Civil engineering is, at its heart, the study of loads and stability. Mechanics, the branch of physics that deals with motion and forces, is the engineer's constant companion. When you apply Newton's laws of motion, you can calculate how much force a column must resist. When you use the principle of equilibrium, you can design a bridge that balances perfectly under heavy loads. Torque explains why tall structures must be anchored deep into the ground to resist turning forces. For example, when a car moves across a bridge, the weight doesn't just press down at one point. Physics distributes that load across beams, trusses, and supports, ensuring the bridge remains stable. Without this understanding, even the strongest material would fail. Civil engineers must also understand how materials behave. Why does steel bend under force but not break easily? Why does concrete resist compression but fail if you try to stretch it? The answers come from physics, concepts like elasticity, plasticity, and the stress-strain relationship. Physics allows engineers to choose the right material for the right job. Steel for reinforcement, because it bends but does not snap. Concrete for foundations, because it resists crushing forces. Even new, advanced materials like composites and polymers are understood through physics. But it's not enough to build structures that stand under normal conditions. Civil engineers must prepare for the forces of nature, gravity, earthquakes, wind, floods, and vibrations. Physics is what allows us to model and counter these forces. During an earthquake, buildings sway back and forth. Physics explains this motion using oscillations and resonance. Engineers then design damping systems that absorb vibrations and prevent collapse. Tall skyscrapers face huge wind loads. Physics allows engineers to calculate aerodynamic drag and design streamlined structures. And dams face constant water pressure. By applying the physics of fluids, engineers design walls that resist the push of millions of tons of water. Every natural challenge has a physical law. Every safe design is the result of applying those laws. Today, civil engineers rely on modern tools, and every one of them is powered by physics. GPS surveying depends on satellite physics and relativity. Non-destructive testing of structures uses waves, from ultrasound to X-rays, to detect cracks without damage. Green building technologies, like solar panels, thermal systems, and fluid circulation, are rooted in physics. Even construction machinery, from cranes to hydraulic lifts, is designed using the principles of mechanics and fluid physics. Physics is not in the background, it is active in every step of civil engineering. As future civil engineers, you are not just learning equations and diagrams. You are learning the language of nature itself. Every formula you study in physics is more than a calculation. It is a tool that will help you build safe homes, strong bridges, and sustainable cities. Physics is what turns equations into real structures. It transforms your knowledge into lasting contributions to society. So, when you study physics, remember, you are learning to design the future. This video is an initiative of the Physical Sciences Consultorium. If you found it useful, do subscribe to our channel for more content on science, technology, and engineering. Explore our other videos to discover how science connects with everyday life and shapes the future of learning.